two parallel rail tracks run north south. Okay, so these are the tracks. Say for example, one track they cannot move, so there are two tracks. Okay, now see, the train A is moving towards north. Say north direction is this and this is the south direction. Okay, so the train B is moving towards south. Okay, this is heading towards south B. Okay, and their speeds are given, rather the 54 kilometer per hour. Train A 54 kilometer per hour. Okay, and the other train is moving with 90 kilometer per hour. Now first of all we have to convert these speeds into meter per second. Okay, so we convert them and then we proceed further. Okay, to convert that 54 kilometer per hour, okay, the train A is moving with 54 kilometer per hour, so 54 kilometer is converted by multiplying 1000, and when hour is having how many seconds? 3600. So just you simplify, this becomes 5, this becomes 18, 2 5s are 2 18s are. So just remember this number 5 by 18. So whenever kilometer per hour is given, you just multiply it by 5 by 18. So 18 3s are you will have, so it becomes 15 meter per second. Similarly, the speed of B you can find, it is 90, and directly multiplied by 5 by 18. So you will have that speed to be 25 meter per second. But one is moving towards north, and towards north moving train or north moving train is A. We take it positive, then this train is moving towards south and we take its velocity to be negative. Okay, now see what is the question. Velocity of B with respect to A. So VB minus VA, just you have to find very easy, minus VA minus 25. Okay, now it's too easy. VB minus VA you can do. Okay, VB minus VA. Okay, so this you can get easily, minus 25 minus 15, so it becomes minus 40 kilometer per second. Okay, now the next question is that you have to find the velocity of ground with respect to B. Now B is moving with 25 meter per second with respect to ground. So it is understood that when we talk about their speed, then it is with respect to ground. Okay, some stationary object, that stationary object is ground. So velocity of B with respect to ground is minus 25 meter per second. Now as you know, ground is having velocity 0. So Vg, okay, Vg is what? 0. Okay, so relative velocity of ground with respect to the velocity of train, so that will be positive 25 meter per second. Okay, now in C, velocity of monkey running on the roof of train A against the motion. Okay, now what is the position? Rather here there is a train, say a train is there, and on it the monkey is moving. Okay, velocity of monkey running on the roof of the train against its motion. Now train A is moving towards north. Okay, if say this is the direction of its motion, then this monkey is moving in the opposite direction. Okay, and its velocity is 18 km per hour with respect to train A. So velocity of monkey with respect to train A is 18 km per hour. Okay, now we want to find out the velocity of monkey, okay, with respect to the standing person on the ground. So that person is standing on the ground and taking the observation. So velocity of the monkey with respect to the person, or the velocity of monkey with respect to the person who is standing on the ground. Okay, that can easily found vma is nothing but velocity of monkey with respect to train a, and that is vm minus va. Now vm is known to you. Okay, velocity of monkey is 18 km per hour, so it is minus 5. Okay, train A is moving in which direction? Train A is moving in the north direction. Okay, and its velocity is taken to be positive. Then this value 18 km per hour, which you convert it into meter per second, then 18 into 5 by 18 if you do, then this becomes 5 meter per second. It is in the south direction, so this value will be minus. Okay, so this is taken to be minus here. Okay, here this is taken to be minus, so vma is vm minus va. Now vma is given, vma is how much? You can see it is given, vma is 18 km per hour, that is minus 5. Okay, so we can easily calculate minus 5 is equal to vm, that is velocity of monkey with respect to ground, minus the velocity of the train A. What is the velocity of train A? It is 15 meter per second. This goes on the other side. So Vm you will have, it is 10 meter per second. Okay, so these are some of the examples of relative velocity. Okay. Now similar example is there in your exercise 3.5 number example. Okay, this I am talking about. A jet airplane travels at the speed of 500 km per hour, ejects its products of combustion at the speed of 15 km per hour relative to the jet plane. So this is the velocity of product with respect to jet plane. So I can write it this way. Okay, velocity of product. Okay, velocity of product with respect to jet plane. Okay, and that velocity is given to us, and that is 1500 kilometer per hour. Now see, try to understand. If you consider this as a jet plane, then this is the product which is coming out. Now see, jet plane is moving in forward direction, then this product is moving in the backward direction, and that velocity if I take minus, then velocity of product with respect to jet is in the opposite direction of the jet, and that is why it is minus. Okay, this velocity as if it is seen by the pilot of the plane. Okay, so that is why it is taken to be velocity of product with respect to the jet plane. Okay, next further we move. Okay, 1500 km per hour, jet airplane is traveling at the speed of 500 km per hour. So we can write the speed of jet plane to be 500 km per hour. So velocity of jet plane, okay, that is equal to 500 km per hour, and it is in forward direction, this direction towards right, that is why we take my positive. Now see, the person who is watching all this thing is on the ground, observer is on the ground and he is stationary. So this is the velocity of jet with respect to the observer who is on the ground. So this velocity is with respect to ground. Okay, now we move further. Relative to the jet. Okay, what is the speed of the latter with respect to observer on the ground? What is the speed of latter? That is velocity of product which is coming out from the nozzle of the jet plane. Okay, that we want to calculate. Now this can be done easily. Velocity of product with respect to jet plane is nothing but velocity of product minus velocity of the jet. Now velocity of product with respect to ground we want to find, and this velocity of jet is given, and that is with respect to ground. Now it is very easy to calculate. Wherever velocity of product with respect to ground is written here, product with respect to jet is written here, it is minus 1500, that is equal to velocity of product with respect to ground. Okay, velocity of product with respect to ground is unknown, that we want to calculate, minus velocity of jet with respect to ground, it is given, and it is 500. So it is very easy that velocity of product with respect to ground will be minus velocity of product with respect to ground will be minus 1000 kilometer per hour. Okay, velocity of product with respect to ground will be minus. Now why minus? Because the product is in left hand direction. Product J, that is moving in left hand direction with respect to the observer. You can see that product is in this direction. Okay, that is why this minus sign has come. Okay. Now numerical number 3.6. Okay, a car moving along the straight highway with a speed of 126 km per hour is brought to stop with a distance of within a distance of 200 meter. What is the retardation of the car? Retardation of car. Okay, we have to assume that uniformly accelerated motion, rather retarded motion, and how long does it take for the car to stop? Okay, so these are the questions. Now you can see that initially the car was moving at the speed of 126 km per hour. So the initial velocity we can calculate v0. Okay, that is equal to 126 kilometer per hour. So we multiply by 5 by 18 and we get it is to be 35 meter per second. Now how much distance does it cover before stopping? It is 200 meter. Now finally when it stops, then we can say final velocity is 0 meter per second. So we can use this v square minus v0 square is equal to 2as, that is distance traveled, and you can simplify it easily. Okay, you can have minus 35 the whole square is equal to 2. Acceleration is to be calculated and distance covered by it is 200, so that acceleration you will have, it is with negative sign. Okay, minus 1225 divided by 400. Okay, and that value will be close to C minus 3.0625 meter per second square. So it's very easy to calculate retarded motion. Final velocity is 0, that is why v square becomes 0. So here 0 minus 35 the whole square we have taken. Okay, now we want to find out the time interval. How much time does it take? Now we have the formula v is equal to v0 plus at. Okay, now easily you can find finally it stops, so 0 is equal to initial velocity 35, okay, minus, because acceleration we got 3.0625 into time for the stopping this car. So time we will get 35 divided by 3.0625 and roundabout you will get 11.42 second. Okay, very easy. Now we talk about the numerical number 3.7. Okay, 3.7 is, okay, the Data is given like this. Two trains A and B of length 400 meter each are moving on two parallel tracks with a uniform speed of 72 km per hour in the same direction. That is the main point here. That is, both are moving in same direction with A ahead of B. One has to be ahead. Okay. The driver of B decides to overtake A because B was behind. He wants to overtake, so he accelerates at the rate of 1 meter per second square, and after 50 seconds the guard of B just brushes past the driver A. What was the original distance between them? What was the original distance between them means the driver and the guard. Try to understand, not the distance between the two trains. Okay, now we move this way. We consider that there are two trains, okay, which are moving in same direction on two different tracks. Try to understand. Now I am showing it this way. This is the first track and this is the second track. Okay, the train A is ahead of train B. Both the trains are of same length and the length of both the trains is given and it is 400 meter. So this is also 400 meter, and the distance between these two trains, the last part of first train, that is A, and the initial part of train B, okay, is x. We consider that this distance is x. Now see, this is point P where the guard of second train is there, and this is the point Q. I want to show it in a different color. Okay, so this is point Q. So P has to reach Q. So how much distance does it travel? You can easily say that it has to travel 400 plus x plus 400. So total distance this P has to cover to say hello to the engine driver of this train A will be 800 plus x. So distance covered will be 800 plus x. Okay. So this is the distance covered. Okay, now initial velocity of B with respect to A, both are moving in same direction with same velocity. Try to understand, same speed rather, direction is same, value of velocity is same. So velocity of B with respect to A is 0 meter per second. Okay, then B wants to accelerate A, so he is rather driver of B is producing acceleration of 1 meter per second square. Okay, and time in which it overtakes or time in which the P reaches Q is 50 seconds. Okay, so now we want to find out this x, that is unknown. So we can use this formula, d is equal to v0t plus half a t square. Distance covered is 800 plus x is equal to initial velocity of b with respect to a is 0 plus, because 0 into t will be 0, 1 by 2, acceleration is 1 into t square, that of 50 square is 2500. Okay, so if you simplify this, okay, then you will get x to be 450 meter. So what is the initial distance between them? Them means the guard of B and engine driver of A. So you can easily now say 400 plus 450 plus 400. So initial distance between the guard and engine driver, that is PQ, that initial distance will be 800 plus 450, so it becomes 1250 meter. Okay, just we have to practice this, okay, so that you can understand which equation can be utilized at what time. Okay, thank you very much.